Hello everyone, Assalamu alaikum. In this tutorial, I'm going to show you how you can calculate network and broadcast address for a given IP address. So for this tutorial, I'm going to use this question written over here. So the IP address will be this one, 2.2.131.2/17. Alright, so this is the slash notation for this IP address. But before moving on to further details, at first we're going to learn some specific topics. At first we're going to learn how we can represent an IP address using binary bits, and then we're also going to learn how we can calculate the subnet mask for a given IP address. Alright, so after learning those two steps, then we will actually move into our actual calculation of network and broadcast address. So at first I'm going to show you how we can calculate the binary for a given IP address. So let's say that our IP address is this one, 2.2.131.2. so this is the IP address given in our question. So I'm going to ignore the slash notation for now. So this is just the actual IP address. Alright, so let's continue. At first we have to find out the binary for the given IP address. So in all of the IP addresses, each octet is represented using 8 bits of binary. Alright, so octet means each of the things that are written between the dots. Alright, so these are known as octets. So there are basically 4 octets. So 1, 2, 3, 4 different octets. So each octet is represented using 8 bits of binary. So now the question is, how can we actually represent these IP address in binary using 8 bits. Alright, so I'm going to represent these two at first using only 8 bits of binary. So you can see that there is a table written over here. So I'm going to use this table to represent my numbers into binary bits. So from this table, I'm going to take only those numbers which can cumulatively create 2. Alright, because I want to find out the binary of 2 in 8 bits. Alright, so I will use this table and I will take only those numbers into consideration which can cumulatively create 2. So here in this table we see that we only need to take this part over here. Alright, 2 to the power 1 which is equal to 1. Alright, so we only need to take this one and we can ignore the rest, because taking only this one can give us the final result as 2. Alright, we don't need any other numbers from this table. Alright, so the number we need, we'll put 1 under that number. Alright, we'll put 1 under that column basically, and we'll put 0 under the rest of the columns. So just like this one, so we just put 1 under this column, the necessary column, and we put 0 under rest of the columns. Alright, so this will be the IP address in binary. Sorry, this will be the binary representation for 2. Alright, so basically the final binary for 2 is 00000010. Alright, starting from left, 00000010. That's it. So this is how you can actually represent a number into its binary. So let's see another example. So I'm keeping the same question here, but this time I want to find out the binary number for 131. Alright, this part over here, 131. So we need to take 2 to the power 7, this thing over here. So this gives us 128. So we're still 3 behind 131, because we want to find the binary for 131, but we're only getting 128 from here. So we still need 3 more. We still need 3 to make it 131. Alright, so how can we make 3 from the rest of the numbers? If we take 64, then it will be more than 131 definitely. If we take 32 or 16, it will also be more than 131. So the only numbers that I can take actually are the rightmost two numbers, 2 to the power 1, which is equal to 1, and 2 to the power 0, which is 2 to the power 1, which is equal to 2, and 2 to the power 0, which is equal to 1. Alright, so basically if we take 2 to the power 7, 2 to the power 1, and 2 to the power 0, then those numbers cumulatively can create 131, which is our desired number. Alright, because 128 plus 2 plus 1 equals to 131. So that's why I'm going to put 1 under only those columns which are actually needed for my calculation, and put 0 under rest of the columns. All right, so basically my diagram will look like this one. So I put 1 under 2 to the power 7, 2 to the power 1, and 2 to the power 0, and the rest of the columns remain 0. All right, so this will be my final binary number for 131, which is actually 10000011, starting from left 10000011. All right, so this is the binary number of 131. So I hope you already got an idea about how you can actually represent a decimal number into its binary version using 8 bits. All right, so let's move into further tasks. But before moving into our next task, I'm going to show you the actual binary for this whole IP address. Okay, previously we calculated binary for 2 and the binary for 131. So now I'm going to write the binary for this whole IP address written over here. All right, so let's find out the binary for this IP address. So 2.2.131.2. all right, I just wrote them in separate columns so that I can demonstrate it in a better way. So I have already calculated the binary for 2 in 8 bits. So that binary is this one, 00000010. all right, so there's another 2, so the binary remains the same. So there's 131. I have also calculated the binary for 131. So this is the binary, and then there's another 2, so this is the binary. So basically the if the IP address is this one, 2.2.131.2, then the whole binary for this IP address will look something like this one. All right, so all of the 4 octets are represented in binary address in this line over here where my mouse cursor is. All right, so let's continue. Now that we know the IP address in binary, now it's time for us to calculate the subnet mask. So our original question was, alright, so now that we know the binary IP address, so it's time for us to calculate the subnet mask for our given question. Alright, so the question was 2.2.131.2/17. So the slash notation is needed right now to calculate the subnet mask. It was not needed to find out the binary representation for our IP address, but the slash notation is actually needed to find out the subnet mask. So the subnet mask for our IP address, this is actually needed for our further calculations. So now I'm going to show how you can actually calculate that subnet mask. So the rule here is that you will put at first you will count how many network bits are there in your question. All right, so as you can see, the slash notation is indicating /17, so that means there are 17 network bits in our question. All right, there are 17 different network bits. All right, so as a result, the subnet mask in binary will have 17 ones in it. Okay, I'm going to write the subnet mask in binary, and that binary will have 17 ones in that. Okay, so let's see how we can represent that. So this will be the subnet mask in binary. So the question indicated that slash notation was actually 17, so that's why in our binary I have put 17 ones at the beginning, and then the rest of the bits are shown as 0. All right, so 17 ones at first and the rest are 0. So this is how you should write the subnet mask for this specific question. If there was something else like /21 or maybe /25, then, or maybe /23, anything else, then you would put those specific number of ones in your subnet mask. All right, so this is how you should calculate the subnet mask for a given IP address. So if I just want to represent this subnet mask in decimal numbers, then it would look something like this: 255.255.128.0. so this is a more familiar figure to ourselves. We actually use subnet mask in this decimal format in our devices. but for our calculation we'll be actually needing the binary. All right, so this is how you can actually calculate the subnet mask for a given IP address. So as we have already calculated the subnet mask and the IP address binary from our question, so now it's time to calculate the network address. So the rule here is a bitwise AND between the two binary of IP address and the subnet mask will give us the network address. Okay, so let's see what I mean. So our question was 2.2.131.2/17, and I have already calculated the subnet mask as 255.255.128.0. all right, so the IP address in binary was something like this. All right, I've already shown you how we can actually calculate the binary IP address for a given IP address, which is in basically decimal version. I have already shown you how you can actually convert that IP address into its equivalent binary number. All right, so this is the IP address in binary, and I have also shown you how you can actually calculate the subnet mask from a given IP address. So that subnet mask in binary looks something like this. All right, so as you can see, both our IP address and the subnet mask are in binary right here. So now I'm going to do a bitwise operation between those two numbers. Okay, I'm going to do a bitwise AND operation. That's what is written here. All right, a bitwise AND operation. So I'm going to do a bitwise AND operation between those two numbers. All right, so I'm assuming that you already know how you can actually create an AND operation between two numbers. Okay, so if you do an AND operation between those two numbers, then the result will look something like this. All right, so just to let you know that 0 and 1, if you put them both into an AND operation, then they will produce 0. So 0 and 1, 0. So the only ones I'm getting here are the ones where I'm getting 2 ones in the input. All right, so there are 2 ones, so that's why the result was 1. This is the basic principle of AND operation. Okay, so by doing AND operation, I'm getting this result over here. All right, so this result is written in binary. Okay, so if I convert it into decimal, then it will produce something like this: 2.2.128.0. okay, so this is the representation for this binary in decimal. Okay, and this will be my actual network address. So the network address for our given IP address is actually this one, 2.2.128.0. so if I want to show you all the things that I have shown till now, the representation will look something like this. So the rule to calculate the network address is that at first I have to calculate the binary of my given IP address. So after calculating the binary of the given IP address, I will also calculate the subnet mask for the given IP, and I will also calculate the binary for that subnet mask. All right, so the IP address in binary is written here, and the subnet mask for that IP is written here in binary too. And finally, a bitwise AND operation between the two, the IP address and the subnet mask, would give us the network address. All right, so both the binary numbers are written, and there's an AND operation between them, and finally we got the network address for our given IP address. So this is how you can actually calculate the network address for a given IP address. Now let's move on to calculating broadcast address. So the question was 2.2.131.2/17, and I have already calculated the subnet mask. So the rule here is that first we have to find out the complement of the binary subnet mask for the given IP address. So I have already calculated both the binary and the decimal subnet mask for our question, right? So the actual subnet mask was this one. So 255.255.128.0. So the binary representation looks like this. Alright, so this is the binary representation for our actual subnet mask. Now we have to find out the complement for this subnet mask. So the complement for this subnet mask will look like this one. So complement means just changing ones into zeros and zeros into ones. Alright, so this is how we can do the complement, and the complement looks like this. So at first we have to find out the complement of the binary subnet mask for our given IP address. So after that, a bitwise OR operation between the network address, which we have just calculated a few moments ago, and the inverted subnet mask, that means this one, the complemented subnet mask, alright, would give us the broadcast address. So there will be an OR operation between the network address and the inverted subnet mask that I have just calculated in the previous step, and that will give me the broadcast address. So let's see the example. So this is the network address which I have calculated a few moments ago, and this is the inverted subnet mask, the complemented subnet mask, alright, that I have just calculated in my previous slide. So now there will be an OR operation between those two numbers. So if I do an OR operation, then the result will look something like this one. Alright, so basically the principle of OR operation is that if you get 1 in any of your inputs, then for those inputs the result will be produced as 1. Alright, so that's why you can see an 1 right there, because we can see that for this column you see that one input is 1 and the other is 0. Since one input is 1, that's why the result is 1, and if you get both zeros, then the result will be zeros. Alright, if you get both 1, then the result will be 1 too, but there is no such example in this specific question. Alright, however, I assume that you already know how you can do an OR operation between two binary numbers. Alright, so after doing the OR operation, the result will look like this. Okay, so if I want to represent this whole binary number into its decimal version, then it will look something like this. So 2.2.255.255. so this is the decimal representation for this binary number. Okay, and basically this binary number or this decimal representation is actually my broadcast address. So this is how you can actually calculate the broadcast address, and if I want to show you all of those things in brief, then it will look something like this one. So how can we calculate the broadcast address? At first we have to find out the complement of the binary subnet mask for the given IP address. So the IP address was this one, subnet mask was this one, and then I calculated the complement of that subnet mask. Alright, so in binary definitely. After that, a bitwise OR operation between the network address and the inverted subnet mask, alright, the complemented subnet mask, would give us the broadcast address. So I have already calculated the complement of the subnet mask, and I did calculate the network address in my previous calculation a few moments ago. So this is the network address and this is the inverted subnet mask, and a simple OR operation between those two addresses, between those two numbers, would produce the broadcast address. Okay, so this is how you can actually calculate the broadcast address for any given IP address. So that's it for this tutorial. So in this tutorial I have shown you how you can calculate the network and broadcast address for a given IP address, and this is how you can actually calculate network and broadcast address for any kind of IP address, any kind of IP address you are given in the question. Alright, so hopefully you have understood it well, and thank you for watching. See you in the next video.